Hi, my name is Isan, and this is my Genius Hour project on the chemistry behind the football helmet, specifically how materials like polycarbonate, foam, and flex panels work to protect players. So, my driving question behind this project is how do the chemical properties of polycarbonate and foam materials in football helmets, combined with modern helmet features like flex panels, improve impact/energy absorption in football helmets? This is a really important topic because head injuries like concussions and CTE are really serious in football. And helmets essentially serve as the first line of defense. So the way they're built from the molecule up makes a huge difference. So here's just a brief overview of what I'm going to be talking about. First, the polycarbonate. That's this outer shell of blue, basically. Polyurethane foam, which is the padding under that shell. And then flex panels, which are along the shell. Those work for impact control. So let's start with the outer shell, which is made of polycarbonate. Polycarbonate is a type of thermoplastic polymer, which means it can be shaped when heated, but also stays solid during use, like in normal temperature environments, like on the football field. Its molecular chains are really bulky and tightly packed, which makes it rigid and hard to break. It also has high tensile strength, which means it resists being pulled and stretched. This is measured in megapascals, and polycarbonate can handle up to 75 megapascals, which is a lot of force. It also has great impact resistance, measured in joules per meter. That tells us how much energy it can take before cracking. Polycarbonate scores really high, between 600 to 850 joules per meter, meaning it's perfect for taking hits on the field. It also resists deformation thanks to some crystalline regions in the structure, which is the areas where polymer chains are more orderly and tightly packed, like those like hexagony crystal-looking things in that molecular structure image. This gives polycarbonate extra stiffness and resistance to bending under pressure and under the impact of those big football hits. Now, inside the helmet is polyurethane foam, which acts sort of as a cushion. And this foam is a viscoelastic material, which means it behaves like both a liquid and a spring. So it slowly deforms when hit and then returns to its original shape. This is really important for energy absorption because when a hit happens, the foam is able to compress, taking in kinetic energy from the blow, but then also rebound slowly, reducing the shock that actually reaches the brain, which is obviously crucial for helping to prevent brain injuries. Its chemistry includes flexible polymer chains that can stretch and bend under force, and plus it's made of closed cells filled with air, which help absorb impact like tiny airbags. That's why the padding looks a little lumpy. That's just air cells. The foam also stays really effective after repeated hits thanks to its durability and chemical stability. So now modern helmets like the Rydell SpeedFlex include things such as flex panels, which are special zones that bend or move slightly when impacted. These panels are made of elastomeric materials, which means they stretch and bend easily, but are able to return to their shape, kind of like that foam I was just talking about. Chemically, elastomers have long polymer chains with flexible bonds, so they deform under pressure and then spring back to their normal shape. Flex panels are placed in high impact zones like the front of the helmet, as you see on that image on the top right. And when they flex, they absorb energy from hit and reduce dangerous forces like rotational acceleration, which can make the brain spin inside the skull. Here's a quick video of just how flexy they are. Like a slight touch can just flex the whole thing. So how do all these layers work together? So essentially, the polycarbonate shell, with its stiff molecular structure and high tensile strength, spreads out the force of an impact. The polyurethane foam, with its viscoelastic properties, absorbs and slows down that force. And the flex panels, with elastomeric chemistry, target and absorb specific dangerous impacts, especially twisting forces. So basically, each layer uses a different type of chemistry, rigid, flexible, and stretchable, to work as a team to protect the brain. Thank you very much for watching.